Thanks, Joe, for the introduction and invitation to come and speak on the series. Great organization, and happy to share some information with the group. I'm actually going to be talking today just a kind of a fun story of restoration on a large natural lake in Iowa, and this is a kind of an unusual situation where we've kind of won a little bit of a war with common carp. Well, I think a lot of fish managers and folks that work on lakes and lake water quality have been working a long time on common carp management and trying to manage a very difficult species. Common carp, of course, are important because they can cause some problems with water quality, habitat degradation, especially when their numbers are high and we have high densities. And we tend to see that this species take advantage of ecosystems and destroy some of this habitat in shallow lakes in particular. And so we're going to be talking about a large natural shallow lake called Lost Island Lake here in northwest Iowa. And it's part of the Prairie Pothole region that reaches down into Iowa. We don't have a lot of natural lakes in the state. They're mostly concentrated in north central and northwest Iowa, which is where my management district is. So we tend to work on a lot of these shallow natural lakes here in this corner of the state. I'd like to acknowledge as well the co-author here for this presentation and for the publication that I'll share with you later on, Jonathan Meerbeek. He's our current natural lakes research biologist in northwest Iowa, works on the natural lakes of Iowa, he and his team, and he's done a really nice job of summarizing this project for anybody that's interested in learning more, taking a look at our data and methods in more depth. So this story actually starts with some stakeholders visiting my office. This would have been back in about 2008, so it's been a long time ago. We had 3 of our Lake Association members from Lost Island come to visit, and they really were interested in stocking more bluegills in Lost Island Lake. They could remember some times when bluegills did well at Lost Island Lake, but bluegill populations seemed to be down, and they really wanted us to stock more bluegills. And so we had a long discussion about why stocking bluegills probably wasn't the answer to their fisheries concerns at Lost Island Lake, that bluegills are more of that kind of canary in the coal mine. They respond to good habitat and good water quality, and their populations tend to do well in healthy natural lakes. When those conditions are degraded, bluegills just don't do very well. And so the signal in the system was a poor bluegill population, but the answer that we talked about was not stocking more of them. So we'll revisit the bluegill issue later, but it's pretty interesting that that's how this started. It wasn't necessarily a water quality issue, but there were some concerns about water quality and also just nuisance algal blooms and a lack of habitat in the lake. So moving forward with that group, and this took a long time, a couple of years to kind of work together with the association, local stakeholders. There's quite a few people that live on Lost Island Lake, and a lot of the smaller communities in that part of the county that rely on Lost Island Lake for some of the economics of the area. Very, very important lake locally to those folks. And so during those discussions, instead of, again, talking about bluegill stocking, we talked about improving water quality and the overall ecological health of Lost Island Lake and its watershed, and why all of those things are important. We kind of set those objectives with 2 fairly common practices. One is, improve the watershed, reduce nutrient input to the lake, and we did that. Our plan to do that through marsh and wetland rehabilitation in the watershed and the connected marshes to Lost Island Lake, but also, of course, improving land management practices, in that watershed, mostly agricultural watershed. And then secondly, we wanted to focus in lake, and some of the work that was done early at Lost Island Lake indicated that around 60 to 65% of the total phosphorus loading at Lost Island Lake was actually internal. It wasn't coming from the watershed. And so we really started to look at common carp as being an issue there. We knew that the population levels were high, the densities were high, but we didn't know until we got into it. We didn't really know what those levels were. But once that goal was set, though, we wanted to restrict critical spawning habitat from these fish. We wanted to do some water level manipulation to control populations in some of the shallow areas around the lake. We did some enhanced predator stalking at Lost Island Lake. I'll share some of that information as well. And then finally, after some of these other things were controlled, we went after the population to reduce biomass. These are long-lived fish species. Just waiting on natural mortality probably isn't an option if you want to see some change. And so we focused on large-scale removal of adult carp, and that'll be the primary focus of the rest of the presentation. To introduce you a little bit about the watershed and the lake system here, I've got the watershed boundary outlined in black for Lost Island Lake, but also Behringer Slough, which Lost Island Lake flows into. Lost Island Lake is about a 1,200 acre natural lake. It's got this 1,000 acre natural marsh that it flows into. It's got some other associated wetlands and marshes in the watershed. And you can see there's actually quite a bit of permanent land protection as well, with those green boundaries being the public lands inside that watershed. Just a general flow of water, the hydrology of the system. The largest portion of the watershed enters there through the Blue Wing Marsh Complex. And then the water exits, like I said, out through Behringer Slough and eventually to the Little Sioux River and is part of the Missouri River Basin. Average depth for the main basin of Lost Island Lake is around 12 feet. For us in Iowa, for natural lakes, that's pretty good. We kind of typically see a little bit better water clarity, better water quality parameters in our natural lakes that average over 10 feet. I think that's probably true for some of the other Midwestern lakes. That seems to be kind of a tipping point for when a lake is deep enough that some of these other perturbations aren't causing an overwhelming amount of water quality issues. And so average depth, but you can definitely see this is a fairly shallow basin, very flat, very typical of a glacial prairie pothole lake. One of the things that we knew that was important, and I've mentioned these, what were these interconnected marshes within the system, within the watershed, and they're important for more than one reason. They should be acting out on the landscape as a way to filter water, as that important kidney that a lot of these natural lakes have, and cleaning water and carrying clean water to the lake. But in the case of Lost Island Lake, like a lot of our natural lake systems, they also can provide critical spawning habitat for common carp. And so we knew just through observation that these common carp were making migratory runs, spawning runs in the spring and early summer up into these marshes, where the habitat was very much degraded. A lot of turbid water in these marshes, lack of underwater plant life there. You can see some cattails, but those cattails would represent probably the majority of the aquatic plant life that we saw in these marshes. And so carp had free reign just to come in. And if you look at some of the infrastructure, which we'll see in the next slide, you'll kind of realize why they had free reign. One of the things that we did on these connected marshes was use water level management to try to increase the amount of aquatic plant life, increase water quality, and eliminate any existing adult populations of common carp in these areas. So we used the recipe from Mother Nature, simulated a drought, did some physical drawdowns of these marshes, which allows for that revegetation to occur, for those seeds to germinate, for emergent plants. And then also we saw a very quick thrush of underwater macrophytes as well, submergent macrophytes as well. So that allowed those marshes to rehabilitate. But without some type of restriction, we also knew that common carp were going to get right back into these areas and start to degrade the habitat and water quality. And so these important pinch points on the water, in the Lost Island Lake watershed and around the lake, had some older existing structures. And as you might imagine, none of these stop carp. They don't stop carp from entering those marshes. They're easily moved through. It should be noted that there were a lot of attempts at putting screens and barriers at some of these locations, but they would always fill with trash or vegetation that was moving through the system and cause some water backup problems and were not very effective at all. And so for the most part, this was a completely open system, open watershed historically. So we invested quite a bit, a little over $1 million on 5 new control structures, 4 water level control structures and 5 fish barriers. This is just an example of the one at the end of Beringer Slough before it entered the stream that goes to the Little Sioux River. Allows for water level manipulation in the front, and then in the backs of those bays, you can actually see some fish grates that keep fish from coming in from downstream, and those fish grates actually go over the top of these control structures as well on the front of the barrier. That kind of resemble this type of a barrier. We call these headbangers, where the fish can swim up under here, but there's enough drop that when a fish tries to jump up and go towards the marsh, they're going to run into that physical barrier structure there. We also invested in an electric barrier. This is a Smith Root electric fish barrier system. One of the culverts in particular, or 4 by 12 foot culvert, blocking entrance to the Blue Wing Marsh complex, was actually a very difficult one. We spent a lot of time trying to engineer something physical, and we really had no alternatives but to end up with an electric fish barrier in this situation. So although expensive, these barriers can be very effective when they're utilized in the right locations. Here's just a picture of the inside of that electric barrier. Those are not the electrodes. It's actually some fiberglass fingers and a retrofit for this barrier. The stream is actually on the other side of those stop logs. The marsh is on the other side of those stop logs. And what we were actually seeing is that common carp would skitter across the top of the electrical barrier, across the top of the water, just outside the electrical field, and get themselves through to the marsh. That's how persistent this species is at getting into those spawning areas. And so these fiberglass, kind of swinging fiberglass fingers, were actually a retrofit to keep fish from going across the surface of the water or skipping across the surface of the water and getting into the marsh. And this barrier would actually knock the fish back into the electrical field where they could be swept back downstream. So just some growing pains that we went through on the project and trying to keep carp out of these spawning areas. So once all of this infrastructure was in place, we kind of set on our last goal of common carp removal from the system. And this isn't an easy thing. We get, especially a lot of stakeholders would ask us, why don't you just remove these fish? Why is that so hard? And so we kind of stepped through the history, and this is Iowa's history with common carp. Shortly after introduction in the late 1800s, a commercial program was put together, and the objective of that was to actually remove carp and some other injurious fish from the state's waters. Shortly after introduction, a lot of the notes from that time show the realization that common carp were a big mistake and that they were spreading very rapidly and causing problems in a number of water bodies. And so this commercial program, the objective there was to try to reduce those numbers. In the 1930s, that market kind of went downhill, and the state of Iowa, the Iowa Conservation Commission at the time, decided to pick up that program and run it with state employees. And from 1930 to 1972, the state rough-fish program worked tirelessly throughout the year, open water and ice, to try to reduce common carp and buffalo populations in the state in our natural lake systems. And they They did show a couple of successes. One of those actually was at Lost Island Lake, another one at East Okoboji Lake, that were published in the American Fishery Society by Earl Rose. But those benefits, the benefits to that reduction was pretty short-lived, and he documents that well in those publications. And so by 1972, a lot more game fish management was taking place and stocking, and there was little success to the state rough fish program. And so in 1972, our current commercial program was put together. And you can see there our objective changed to that program, and it was no longer to reduce numbers. We didn't think that was possible, or at least sustainable. And the objective changed to just the utilization of an unused protein source. And so that commercial program still runs today, and we still administer that on a yearly basis. So what did we think we're going to do that's different? And why did we think we could have some success here? If nobody, previous to us could do it, why did we think we could? Well, there's better research there. University of Minnesota, South Dakota State. There's some good work being done on the life history of carp. Their spawning locations, predators that may be eating fry and young. There's some good work being done there. There's certainly room for more. And I hope that continues with this important species. And we knew going into this that recruitment control was going to be a key factor here. And we knew that recruitment was mainly occurring in those marshes through some of the research that had been done. We set biomass goals. So we did population and biomass estimates throughout this project. Very, very labor and time intensive. And so that work was very key, though, and instrumental in setting some of the goals that we had for reduction. And then we subsidized the commercial harvest. So we actually added some incentive here. We knew just through the length of the program that commercial anglers aren't going to stick around when catch rates start to fall. They're profit driven. They have other lakes that they can fish. They may have contracts on. And so when catches go down about the time when we want them to continue fishing, they just simply pull up stakes and move to another lake to increase their catch. And so to keep them fishing, we knew we had to subsidize that harvest. We had some great partners here. I won't go into all of them. I've got a list at the end, but we had a lot of partners working with us on this project towards a common goal. And a lot of that focused on good public education and support. So everybody got to become carp experts and watershed experts along with us on this project, and that was really important for a long-term success. So I'll focus a little bit on this carp subsidy and what those contracts look like. So back in 2010, after a lot of the recruitment control work was done through those fish barriers, we put a contract together, and we knew that the commercial program in the past had done around 200,000 pounds of common carp in a single year for removal. So we knew that was attainable by a commercial angler on their own. And so we set that as a minimum. So they had to do this on their own. 15 seine hauls. They used these large seines, shallow seines, to actually encircle the fish and pull them into shore to land those nets. So this was the minimum. After that minimum, we essentially doubled the price per pound of live carp for sale. So the price for carp was running at the time at around 15 to 19 cents per pound. We essentially doubled that price for them. So every pound over 200,000 pounds got 15 cents. And then we put together some cash bonuses. $8,000 for reaching 300,000 pounds. And our target for this project was actually 400,000 pounds of removal. And we put another $12,000 cash bonus there. So if you did the math, this is totals up to be around $50,000 in subsidy that is available for the commercial angler if they meet the goal of 400,000 pounds. So how did that turn out for us? They harvested 431,900 pounds of carp during that contract period. They also took about 353,000 pounds of bigmouth buffalo. These buffalo have a higher market value and could be playing into why the angler was actually interested in staying around on top of the bonus structure that we had put together and the subsidy structure that we had put together for them. So a big biomass reduction for this lake. 2011, the following contract cycle, we put together another little bit of a subsidy. They were able to harvest another 63,000 pounds of carp and 60,000 pounds of buffalo. So what does that look like? If we look at that, traditionally, kind of the commercial removal from 1984 up to the time we put that contract together, you can see the buffalo and carp removal there at about, and that was that year, in 1999 when we saw about 200,000 pounds of common carp removed, which set our kind of initial target. And then if you look at the contract year 2010, which actually went over 2 calendar years, you can see that large removal effort that took place under that subsidy and bonus structure. That amounted to about, and then subsequent to that, some additional harvest that's occurred. And I should note, I don't have the last year on here, 2022, but there's been no harvest of carp and buffalo since that time of 2020 and 2020, since 2020. That looks like a lot of fish, and it is 891,000 pounds with the combination of those years there. About 743 pounds per acre, if you like to look at it as in a form of density, or pounds of fish flesh there. It's important to note too there that that's not an instantaneous value, that the fish are growing during this time. And I've got a graph that shows how quickly these fish grew once their population density decreased. But it just gives you an idea of scale there for biomass. And then if you put all those numbers together, since the time the project started, 1.4 million pounds of fish that have been removed out of that system. So was that enough? We can look at that a little different way. In the next couple slides here, I'll show you just kind of how that population density and population numbers changed. But first, I've got a couple slides here to just show the scale of some of these operations for removal. We actually have a variety of different commercial entities that work on our lakes here in Iowa. Everything from these larger scale operations using tractors and they're highly mechanized to some 4- and 5-man crews that do some seining for us. So this is actually from Lost Island during that contract period, an ice haul that was done underneath the water. These seines can be up to 2,000-3,000 feet in length. We've had a commercial angler that had a seine that was around 9,200 feet, almost 2 miles of net under the water. This is actually the takeout haul. This particular haul had about 150,000 pounds of just common carp in it. And this is just the takeout hole where you can imagine a large balloon of common carp underneath the ice here, and they would harvest those fish out. All game fish are removed immediately. They have to be sorted on the day of the seine. So all non-target species, I should say, not game and non-game species, have to be released immediately into a hole outside of the seine. And then these fish are taken out of the hole and then sorted on a large sorting table. And then they're put into catch, basically keeps underneath the ice, and the semi trucks are called. The commercial angler will work with a hauler to actually haul these fish to market. I should say almost all, if not all, of the fish that were harvested during this project were used for human consumption. The big markets are New York and Chicago. There was a time when a lot of fish from Iowa were actually heading into Canada to some of the commercial markets there. So getting back to the common carp population and what we were able to do there, these are again based on catch and mark and recapture estimates and some catch effort models that were produced after a few years of putting together the population estimates through mark and recapture. And really, our goal in this project was, and kind of some of the research indicates that this 100-pound per acre threshold, or I think it's 95 or 90 kilograms per hectare. The goal there is to reduce that biomass below there, and the reason is the research indicates that the lake and water quality should respond to that lowered level. And as you can see, we made it pounds per acre there. We're actually hovering in the last 5 years. We're hovering somewhere around 40 to 50 pounds per acre of common carp in the lake. And you can see where we started. We were close to 350 pounds per acre of carp biomass in this system, which doesn't leave a lot of room for anything else, especially when you account for the bigmouth buffalo population that was there. Some things that we saw. This is just a length frequency diagram looking at percent frequency of different lengths of common carp in 2008. You see the inch groups on the bottom of the screen there. Right after that harvest, we actually saw these fish grow pretty dramatically. Within just a few years, the average weights went way up. And this is percent frequency. So these numbers in 2015 are very much reduced. We'll get a little bit into the catch effort for our sampling, but that is really reduced. The reason I put this up here is, as a fisheries biologist, you want to, and we're trying to control recruitment. We don't want to see little fish. And we've seen since the time of the project, we've seen very little recruitment into the population at Lost Island Lake. And that's a great sign of success there. Again, I mentioned the average weight. After the project, you can really see the mean weight of common carp increase as their density decreased or was decreased. That they were fairly old fish at very small sizes, and which was a probably density dependent growth there, density restricted growth. And as soon as we did that harvest event, we started to get larger and larger fish, and that, again, as a fisheries biologist, you want to see an older and larger sized fish in the population means probably low density. Just a quick look. I don't want to go through all of this. Just some of the predators that we and kind of this enhanced predator stocking that we did at Lost Island Lake. And a couple of things to note here are these largemouth bass and northern pike that we typically don't do a lot of stocking in of these two species in the lake, and especially these 11-inch northern pike. But again, we're really focused here on making sure that we're filling that void, trying to get a predator top-heavy environment where the rest of the fishery can kind of respond and get healthy. And I'll show some results of that here, not just the stocking, but the recovery of the population. But first, just to think a little bit about water quality. A couple of parameters here, Secchi in red, Secchi depth in feet. Our statewide goal for our restoration program is around 4.5 feet average summer Secchi. That's we consider that a success for our Iowa lakes. And as you can see, we're attaining that over the last several years. We're getting really close and attaining that in those years. The other factor to look at there is turbidity, and we've seen a significant decrease in turbidity there, which would be another indicator of some shifts in the ecology. Aquatic plants are really important. We know that they respond well to improved water clarity, and we also know that they have a feedback mechanism that helps stabilize the ecology of a natural lake and any lake, really. But just to kind of look back at some of the historic surveys that were done at Lost Island Lake in 1996, that pretty large survey found one cattail in the lake. So that was the extent of our aquatic plant life at Lost Island Lake in 1996. In 2001, Iowa Lakes Community College did the same survey, and I think they found the same cattail in the same location. So that was a pretty barren place. In 2012, shortly after the project and the removal, we actually saw a quick rebound. 6 species showed up. 28 of our 30 transects had aquatic plants. In 2018, that number jumped to 8 species. By 2019, we're at 10 species with all of our transects having aquatic plants. Just some quick fisheries information. This is daytime electrofishing. So this just is fish per hour. Common carp numbers there in the sampling that we did from 2009 through 2010, 171 common carp per hour, that is just painful on the front end of an electrofishing boat to be pulling in that many carp per hour. By 2018, 2020, the surveys that we did during those years, we averaged around 5.1 carp per hour. And you can see there just the response in some of the more desirable fish, some of the fish that would indicate some better water clarity, and especially those bluegills going from not finding one to 22.5 per hour for daytime electrofishing. Some really neat responses there in the fishery. So just to kind of wrap things up a little bit, some final thoughts on this. We had, I can't say enough for the local support and also the enthusiasm. We had an awesome lake association there, the Lost Island Lake Protective Association, and I'd say the Palo Alto County Conservation Board. Between the two of those groups, just an amazing amount of fundraising and work, door-to-door sales that went on with these folks to really sell this project and keep everybody informed throughout. Our subsidy was effective. We were able to lower that population, and we keep saying this. Jonathan and I keep saying this, that we were successful in reducing common carp recruitment so far, and every year that distance from the project gets further and further. So we saw a positive aquatic plant and water quality response. Recreational use, fishing and recreational uses increased substantially on the lake. We've seen a really big increase in the usage. We're pretty proud of this. Lost Island Lake was removed from Iowa's impaired water list in 2018. This is great news, and one of the few times we've been able to take a large natural lake and move it off of the impaired waters list. And we now have, after a lot of years of working on justification and doing some work there, we have an active watershed improvement project ongoing. And again, I think that will add to the sustainability and resiliency of the system into the future. There's been a lot of conversations in especially the upper Midwest, about bigmouth buffalo populations. We know in Iowa they act a little differently than maybe to the north, where they're probably longer lived and maybe more susceptible to commercial harvest and harvest in general. We don't necessarily see that in Iowa. And we also know that in really high densities, they probably can be a factor in water quality and kind of the ecosystem. So we still have some questions about how important the bigmouth buffalo population was in this whole project, and that needs some more work. So to finish this out, I'm going to go back to this question: why don't we have any bluegills? And so we're going to look at. We just happen to have this little 50-foot beach seine that we had run on, looking actually at walleye young of the year is one of our indicators of fry stocking success. But we enumerated since 1970s. We've actually counted all of the fish that we catch in these, and they're mostly young of the year. This is a seine pull that's done at night along the shoreline. Just a nice little short haul. Count everything that's in the net, and we've kept track of that through time. This is the number of age 0 bluegills per haul, and those are those little guys there. There's some crappies, but you can see the little bluegills in the palm of my hand there on that photo that we catch in that seine. Through 2008, 0, next to 0, hardly ever see a bluegill in that seine. Well, shortly after the project, those numbers started to increase. We saw, over 100 per seine haul. In the next few years, we jumped to 600 to 700 of these little guys in the seine, and then you can kind of predict what's going to happen here. We saw just the numbers explode, just over 4,000 per seine haul, these young bluegills, and the adult population has recovered as well and is starting to become quite a fishery there at Lost Island Lake. So kind of a neat way to round that out and bring it kind of full circle. Just an example of what those seine hauls look like in 2022. Just some really good healthy indicators of a healthy fishery and thus a healthy ecosystem. And then a quote from a lake resident, longtime visitor, just fun to feel, fun to see these come into the inbox. We don't always see the positive. A lot of times we see the complaints, but just a great quote from a longtime resident there at the lake that really drives home the fact that we've seen an amazing change at the lake. So with that, I'll kind of acknowledge some of the partners. We had a bunch of them on this project, a lot of funding partners, a lot of technical expertise. I don't want to minimize our Wildlife Bureau for all their expertise and work on this project and help with water level manipulation, water level management. Those guys really know what they're doing. And with that, I think we've got some time for questions. And then if anybody wants to know more about this project, like I said at the beginning, John Meerbeek wrote an excellent summary of this project with all the data. All of the work that was done here is really well summarized in this. And you can find that at ResearchGate. If you just do a Google search, ResearchGate and Lost Island Lake Restoration, you'll land right on it. So thanks.
Awesome. Well, thank you, Mike. And that's just an incredible, the bluegill graph that you showed at the end is just incredible. Some of the electrofishing surveys as well really speaks to the turnaround you guys have pulled off on the lake. And yeah, that quote says it all,
Yeah,
catching fish, right, swimming, enjoying the lake. So thank you. That's a really neat project. And I appreciate you sharing it with us. For those of you that are looking at the screen now, we will be able to share this information with you, including the link to the paper. So don't feel like you have to write down that hyperlink if that's intimidating.
It is a big one.
Yeah. So I'm going to take this moment to just remind folks, if you have questions for Mike, go ahead and use the Q&A function to submit those questions. We've got 8 in the queue right now. Of course, I always have questions. I'm always curious to learn more about these, but I'll hold my questions till the end and I'll let you guys ask questions first. So go ahead and fire away your questions. I'm going to ask them of Mike, and we'll go. We've got up to about 20 minutes for the conversation. So Mike, the first one is a question that I think you started to touch on in one of your slides. The question is, are bigmouth invasive in Iowa? And I think, sort of touching on some of the research that you alluded to, bigmouth buffalo being longer lived and being a native species, at least across much of the upper Midwest. I'm not positive about this particular system. Can you talk about the social considerations that you guys weighed in your fishing programs for bigmouth buffalo as opposed to common carp?
Yeah, so it really hasn't changed much through time. In Iowa, they're listed as an injurious fish. We don't really necessarily, our code is kind of all over the place with that. They have been part of the commercial program for a long time. And, they were considered a rough fish. I don't necessarily consider them a rough fish at all. They're native to our waters here, as are a few smallmouth buffalo in the Missouri River Basin. But bigmouth buffalo, I believe, can take advantage of some poor habitat. They seem to do well in these perturbed shallow lakes, and we start to see some really, some really big populations of them. And so, yeah, I think they're doing just fine in most of our waters. Like I said, we don't see the really long-lived ones here, and we certainly had a lot of harvest on them for a lot of years. You could see that harvest there at Lost Island Lake, and without a lot of impact to the population. But certainly something we want to learn more about. I think I mentioned it there. We need some additional work on bigmouth buffalo in this state. And their role in water quality, and we know they're planktivores, so they can have some definite impact on the food chain.
Yeah, great, thanks. All right, the next question is about aquatic plants. So, which aquatic plants were the first to come back into the lake once you guys started seeing the restoration take hold?
Yeah, I kind of like to think of them as early successors. They're usually. Sago pondweed is one that comes back. This particular water body doesn't have a history of curly-leaf pondweed, which is really great. That's not normally, not that we're not going to get it there, but That's nice to have just a native plant community. However, this past year, we did see Eurasian water milfoil for the first time, and we're actually aggressively going after that. We don't want that to become an issue there at Lost Island Lake. So we're currently working on plans for trying to eradicate that plant at Lost Island Lake. But sago pondweed and coontail, I would say, are the two species that we see probably colonizing the quickest if curly pondweed's not there.
Yeah, okay, thanks. And a little bit more about the drawdown. How long did the water drawdown last?
Yeah, so it's important to note here, the main lake, we did not do a water level drawdown on the main lake. So it was mostly just the marshes that we worked on. And we did two, well, it depends on the one that we're talking about, but generally we're doing a 2-season, so 2 growing season drawdown on those before water is allowed to slowly come back in. So 2 springs for drawdown.
Okay, thanks. All right. So another question is, in the end, what was the total cost of the subsidy?
That subsidy just on its own, and again, we're talking about a little over $1 million in infrastructure there and a lot of engineering costs. The subsidy on its own was $50,000. So when you think of it in terms of the overall project cost, it was not a big price to pay for a major component of the project. And I do see a kind of a follow up there. There's no and confirm there's no commercial fishing in the last decade. That actually we have had commercial fishing there, just there's not been much success. The plants get in their way. Those seines don't like to go through aquatic plants, and population levels are very, very low at this point. So they're not gonna catch much when they do fish. So the last 3 years we have not seen any commercial harvest.
Do you guys have a threshold by which you'll decide to try to re-engage that commercial harvest or those subsidies?
Those commercial contracts are available for bidding. So they in Iowa, it's a sealed bid process, and so they submit a bid for a lake when it's open for rebid. So we usually keep those lakes on the list, and a commercial angler can bid on a lake if they want it. Once they get a lake, they can renew up to 3 years. That's how our commercial program works, which is very different than, say, Minnesota, where a commercial angler will have a lake for life, basically.
Okay, thanks. All right. When you looked at the host of mouths that you were going to stock in the lake, were muskies considered in that predator program? And this person, notes that they're obviously larger, they do well in warm climates, and they tend to prefer larger prey species, so they might be more effective predators. Did you guys consider muskies at all?
We definitely did. We've got a short list of lakes. It's actually grown a little bit in Iowa where we manage muskies, and we've got a pretty successful project. So it is actually a species that was considered. We actually even considered hybrid muskies, a tiger muskie there as well. That's a program that we haven't had in Iowa for a long time. So that would be a species that was considered. We really, the research is really pointing for carp predation is really pointing at bluegills. So bluegills are probably a really important species for fry and egg consumption. And so I think that panfish population is probably as important as some of the larger predators.
Don't underestimate the little guys.
Yeah.
Are they? And you said that the growth rates were pretty good for the bluegill, and do you expect to see quality sizes coming through? I think what you showed earlier was you're getting a lot of numbers of small ones right now.
Mm-hmm. Yeah, we have seen in natural lakes that are restored. It seems like the growth rates are really good. We have plenty of productivity here. We're at the high end of productivity for the world, and so our productivity usually isn't a problem. Plenty of resources to go around. We do see some slow growth in panfish once in a while, and this would be a time, early on as these bluegills are repopulating, that you might see a slowdown as the predator population tends to catch up. They're older fish, grow slower. And so you definitely might see some slow growth to start, but I would hope that would take care of itself pretty quickly.
Okay, gotcha. All right. So this person asked, do you have any tips or strategies or snags you hit while educating the public on the benefits of water level management? Avoiding the dreaded D word. I think they mean drawdown, but maybe dam.
Dredge, I bet.
Oh, thank you. Yeah. Did you run into any issues with restricting northern pike spawning habitat after installing the carp preventative measures?
That I'll answer the second part there. The northern pike was definitely considered, which is one of the reasons we continue to stock some of those fish there. We knew that blocking these marshes off does interfere with some life cycles and some life history migrations that these fish might go through. So, yeah, northern pike, their population seems to be doing okay there. We backed off on stocking, so they're finding some places to pull off spawns. So, and then going to the dreaded D word and water level management. I think we've had a number. It's kind of split with stakeholders. I think we've had enough successes in Iowa. They see some successes across the border in Minnesota, for example. Wisconsin has had some good successes, and they like what they see after these restoration projects and drawdowns. In this particular project, we didn't really affect any recreational water or boating water with drawdowns. These were mostly marshes that we were working on. And so that wasn't as big of a deal. We are working on currently some drawdown projects where there's been a lot of education on drawdowns and why we're doing it, what the benefits are, that there is going to be a kind of a lag as a fishery responds after we restock it after the carp are gone. But boy, we really concentrate on common carp and that they're really, in some cases, that's still the easiest thing to do is to completely reset that fishery. This isn't easy to do. Common carp population manipulation and management, biomanipulation of a population like this is very, very difficult. And then dredging always comes up. We do a lot of, we have a history of dredging in Iowa, and it's difficult to move away from that. Although we do have some examples of where dredging has not worked to improve water quality, and that shows that this very, very expensive process of dredging may not have the benefits that we thought it once did. And so we've learned some things about dredging and where it does work strategically in some forebay areas and where it doesn't work, like on a main lake of a large natural lake.
Okay, thanks. We've got the number of questions is increasing, not decreasing. So you're spurring interest and curious minds. And I'll just mention to folks, we'll try to get as many as we can in. And then, we'll include Mike's contact information if we aren't able to get to them all. So you mentioned, that this has been successful and some of the you alluded to trying it in other places. Do you have experience with where it's been successful or not, looking at other lakes, other systems, and what have you learned in that process of trying to expand this out?
Yeah, I mean, there's an important topic here kind of laying underneath is have we tried this, in other places, and can we take this show on the road and do it in other locations? And so far, the answer is we've not been very successful at that. So we've actually tried to do some carp manipulation projects in some other lakes, and it has mostly to do with the aggressiveness of the commercial angler and trying to figure out where that incentive line lays. We're trying to figure out what is enough incentive to actually get them to do what we need them to do. So it's not necessarily we don't think we can do it again, because I think we can in a couple lakes that we're working on currently. It's getting the motivation of that commercial angler to go do it. And so we're trying a couple new things right now, actually, as we speak. We've gotten some approval to move forward with some new contracts. So we'll maybe update folks at a later date on how well that's working. But put a little bit more money on the line. We know how important this is, and we need it done. So let's pay for it. And so we're investing some serious dollars on a couple projects right now. You know, I think I know recruitment control, to kind of answer the other part of that question, recruitment control alone, I think long-term can probably be an effective strategy. You just got to realize that it's not going to be right away. You're not going to have that immediate impact like we saw at Lost Island.
Yeah, for sure. All right. You mentioned that there were, dramatic increases in aquatic vegetation. What was the public's response to that increase in aquatic vegetation? Now, they used to have poor water quality, and now they've got clear water, but a lot of aquatic plants that may be, in their way and they may not be used to.
So we did a ton of education on the front end. In fact, the Lake Association knew, and really they were on the lookout for aquatic plants, because they knew if they saw aquatic plants, it meant we were actually moving the needle, and we were seeing some progress. And so the association especially was really well educated on this, and they did a good job of communicating out that this is what progress looks like. Even with all of that, that is probably the number one complaint that I see into my office now is aquatic plants at Lost Island Lake. So that success that we've had there has come with some growing pains. And I think one of the biggest challenges there is recreational boating traffic and tubing and skiing and things like that, where the prop action of those boats will cut up a lot of those plants, and those loose plants will then come to shore. And when they come to shore and they wrap on people's docks and hoists and up on their shorelines, and they start to stink, that becomes a big issue. And I don't know of a good solution for that. We're certainly not going to go treat all of that aquatic plant material. Even if we did some spot treatments of those aquatic plants, that probably isn't going to solve the problem of boat chop and the boats chopping up some of that plant life. So I think it's going to be just getting used to it. This is what Lost Island looks like now, and this is a healthier lake. And I think when you just keep up that educational effort, that's the only thing we can do. I don't know what else to do. So having good resource materials too, and that may be something for the partnership to think about, is having those good resource materials out there, like you guys have done for shoreline management on natural lakes. That's really important to be able to hand somebody something or send them a link for more information.
You know that you've got macrophyte enthusiasts here in the MGLP, and we're happy to proselytize. So that's a good idea. I know Eric, our co-host, is salivating at that thought.
Yeah.
All right. You mentioned Secchi and turbidity. Did you guys track phosphorus as well? And what did you see in that relationship?
Not as much of a relationship. I thought that question might come up. I was actually looking at it last night just to see. I keep wanting to see a pattern there. I think we've seen an overall decrease in total phosphorus, but I think part of the problem is our sampling is 3 times a year. It's a little bit variable on timing. I think a better spatial data set would probably show us a little bit more in total phosphorus for the system, but it's trended down. So is chlorophyll A, but they haven't trended nearly as much as Secchi and turbidity.
Yeah. Okay. Thanks. There's always something that's a little bit complicated. Let's see. I'm trying to. Will the removals of carp need to happen indefinitely into the future to maintain the current fish community and ecosystem?
Well, the title
to that a little bit, but
yeah, the title of my presentation is "We're in it for the long haul." So we're committed as an agency of working on this project. Again, I think if that were to be an issue, I think we could do a redo. I mean, I think we could, if populations for some reason all of a sudden exploded and our habitat degraded, we'd do it again. I think we try it again and try to, we've learned a lot. We have a great catch effort model for Lost Island Lake for adult carp. So we don't have to do all that mark and recapture again. And so we would just engage our commercial angler again, or figure out a different way to control that population. But I think we would definitely be there if we needed to be.
And if commercial harvest was difficult, maybe because of the aquatic vegetation, what other methods are available for capturing those carp?
Well, I'm keeping my eyes on the YY technology, the Trojan mail, Trojan mail stuff that's going on work out of the University of Idaho. That's some pretty exciting work. And when you couple that with some commercial harvest, you can probably have some fairly quick impacts there. So that's one thing I'm really keeping an eye on.
Can you say just a little bit more for folks that maybe aren't familiar with the YY project? Just explain what that means.
Right. So they're introducing male fish with double Y chromosomes, and so they can only have male offspring, and not genetically modified. Just they use use a technique when the fish are young to do sex reversals on those fish, and then spawn, then use them as parent stocks so that they can create a brood stock source, and then stocking source for these double Y chromosome carp. So, and the long-lived fish is probably going to be a little more challenging, but couple of stocking regimen, the models show that with commercial harvest, then we might be able to crash a population. So we're on the edge of something there, I think, and some of that's already been successfully deployed against brook trout in non-native areas down in the Southwest. I just saw a paper come through from in the North American fisheries management.
Yeah. Okay. Great. Thank you. All right. Well, looking at the clock, it's 3:01 here in Michigan and 2:01 probably where most of you all are. So I think at this point, it's time to again say thank you to Mike for sharing your experience and information about this. I've learned a ton, and I'm sure that everybody else has as well. We've still got 70-something people hanging around listening to the questions. So clearly an engaging presentation. Thank you, Mike, for taking the time to share with us. We've got his contact information here on the screen, and after the webinar is done, I will email a recording of the webinar as well as contact information in this paper to everybody that registered for the webinar. So again, you'll be able to share it, go back and rewatch it, and you'll also be able to follow up with Mike. I apologize we weren't able to get to everybody's questions today, but that means that we had a stimulating conversation, so that's a good thing. So with that, I think we'll wrap things up. And I believe our next webinar is on the 28th. So tune in for our next webinar from the MGLP, and we will see you all in a couple of weeks. Thank you.